Welcome back, everybody. We are plunging into a new unit despite all the chaos from the test last week. We are going back to chapter 2. Remember, I skip around in the book, so hang on to your seats, and here we go. Properties of matter. They talk about a lot of kind of strange things. Some of the stuff's really applicable, but they always show food, it seems like, in all their pictures in our book. Anyway, bamboo. It is not a pure substance, so we'll move on from there. Matter has mass and takes up space. We've already gone over that a little bit, so I'm not going to spend a lot of time on that. Remember, mass is how much stuff or material is in the object. It is related to weight, but it's not the same thing exactly. Volume, as you know, is the amount of space the object occupies. Properties, as we've also talked about, can be extensive or intensive. If it's extensive, it depends on how much of the stuff you have. So how big of a sample. The bigger the sample of anything, the greater the mass. Also, the more of anything you have, the bigger space it will occupy. Intensive properties, on the other hand, are properties that only depend on the type of matter, not how much of it. It doesn't matter if you have 5 grams of water, 5,000 grams of water, 5 million grams of water, it still has the same boiling point for the same atmospheric pressure. Density also stays constant. This is for pure substances, okay? And we can use these intensive properties to help us identify what a substance is. Every pure substance has identical intensive properties. Okay? If you have a pure substance with uniform composition, not uniform distribution, but the same kind of atoms or the same kind of molecules, it's what we call a pure substance. Okay? So only elements or compounds. Everything else is a mixture. And physical properties are one type of property we can use. Sometimes it helps us identify things. And we look at physical properties and we don't change what the material is. So the color of it, which sometimes is helpful, but not that often, surprisingly, especially for minerals and things. The hardness of it, which is a property that's used to identify minerals. MP is for melting point, BP is for boiling point. So again, color, the state at room temperature. Room temperature is usually taken to be about 20 degrees Celsius. Conductivity, does it conduct electrical current? What the melting points and boiling points are. Malleability, how bendable is it? These are all types of physical properties, and they can help guide us into determining what a substance is. And sometimes, like with melting point and boiling point, we can maybe even get the correct answer. So here are some gases up at the top, and then some sodium chloride is a compound, but these are, of course, sulfur, gold, and copper are elements. So there are some gases that have colors, but a lot of them are colorless. There are some liquids that have colors, but a lot of them are colorless. Almost all the metals are silver and shiny in color and reflection, but that doesn't help us identify them necessarily. So chemical properties are properties that we can only observe when the substance is actually undergoing a change, when it's not going to be the same thing at the end that you started with. So reactivity, what does it interact with? Toxicity, how much of it will kill you? Flammability, obviously that's fire. What kind of bonds are formed? And again, that's not something you can look at with your eyeballs, but you would have to break the substance apart to see the bonds. Heat of combustion, how much energy does it release when it combusts? These are all chemical properties. And these can also help us determine the identity of a substance. All right, we're going to skip to probably early grammar school stuff, states of matter. The book says there's 3 states of matter. Actually, there's a 4th one, but we'll talk about that in a sec. So solids have definite shape and definite volume. Everybody's kind of locked in place. They're still moving, okay? Everything's still moving until you get to absolute zero, which we can't get to, but they don't move away from each other. Liquids have indefinite shape. They take the shape of their container, but the volume is fixed or definite. And then atoms or molecules in these in liquids are able to move around each other. So when something's melted, or does, then those atoms or molecules are free to change places, but the volume doesn't change for a specific temperature. Gases are matter, form of matter that takes up the shape and the volume of its container, so it's indefinite shape and indefinite volume. However big the container is, they will expand and keep on moving. It's one of those Newton's laws kind of things, you know, keeps on moving in a straight line path until acted upon by an outside force. So everything's going to keep flying around in whatever container it's in. So again, definite volume, yes, yes, no. Definite shape, yes, no, and no. And temperature increase, usually as the temperature increases, solids will expand a little bit. Same with liquids. You can even notice that, like boiling water in a pot. I make up a lot of hummingbird food, and I do notice the expansion as the water comes up to boiling. Gases, huge expansion changes if you heat them up. Think hot air balloon. Are they compressible? No. Solids aren't compressible. Okay. Pure solids. You think of foam or bread or marshmallows. Those actually are what we call foams, and they are they're not they're colloidal systems, and they are not true solids. There's air in there, gas and solid together. Liquids, no, everybody gets this one wrong because everybody thinks, oh, I can move around in a swimming pool, it must compress. But just stop and think for a second about doing a belly flop. Most of us have done one of those at some point in our lives, and you know that the liquid won't compress. Will your mass push aside the volume of water? Yes, but if you hit it right, you know they don't compress. Gases, of course, are very compressible. We can squish things with gases in them, and that's because they are very far apart from one another, about 10 times their diameter on average. Vapor is another word for gas. It is what we talk about when a substance isn't at its boiling point, but it is in the gas state. So humidity is water vapor in the air. It's a measure of how many water molecules are in the air for a given temperature. Again, it's not because we're at the boiling point of water that water can be in the atmosphere. Okay. There is a fourth state of matter, and probably several of you know it. It is plasma. It only occurs on probably in stars and in special reactors. It is a state of matter where there's charged particles, so the electrons get stripped off of the nuclei, so you get positive and negative particles flying around. That's what causes the aurora on planet Earth. The solar winds are plasma blasting at us from 93 million miles away. They're what we call ionized. Ions are particles that have charges. They have more or fewer, in this case, electrons than they're supposed to for their number of protons. Physical changes can be classified in different ways. A physical change may change the appearance of a substance, but it's not going to change what it is. It doesn't change its composition. So if you boil something, you melt something, you cut it, you bend it, you split it, you crack it, it's going to change its physical appearance, but this log is still a log. The girl's hair is still braided, it's still hair. The can is still made of metal. The arch, the sandstone arch, is still sandstone. Okay, the chocolate, oh, it's so sad it melted. The chocolate is still chocolate. Okay? It's just in a different state of matter or changed shape. So some of the properties may change, but the composition doesn't change. Gallium is one of the elements on the periodic table that actually has a melting point lower than your body temperature. And if we were together, I'd bring in a sample of gallium and show you. It will melt in my pocket, kind of like chocolate, but don't eat it. Physical changes can be classified as reversible or irreversible. This is where people get into problems with physical changes. You cut the hair, you break the egg, that's not reversible. Okay, but it's still egg, it's still hair. Okay, so sometimes you can reverse it. You can melt an ice cube, you can boil water, you can also condense the steam and make liquid water and back to an ice cube again. So that is reversible. But things are also physical changes that are irreversible. So what's it called when a solid becomes a liquid and a gas? Everybody knows for a solid to become a liquid, it has to melt. That's the process. Evaporate for a liquid to become a gas. You could also have boiling, but it doesn't have to. Okay. Gases will condense back into liquids. Think your bathroom mirror in the morning. And liquids will freeze into solids. Anything that's a solid is frozen, even if it's not at the freezing temperature of water. Chemical changes happen when new matter, a new type of matter forms. Rusting of iron is the reaction of the iron atoms with the oxygen in the air to make a compound. Burning things always is a chemical change. Again, it's reacting with oxygen in the air to make something new. Decomposition, things rotting and that icky stuff, they are changing what they are. Fermentation, okay, is another form. Again, you got your little yeast or whatever, changing sugars into alcohol. That's fermentation. So the decomposition of leaves, the cooking of an egg, the tarnish on a penny, the burning of a log, those are all chemical changes. There's something new. Okay, we've denatured the protein. We don't have wood anymore. We have carbon dioxide and thermal energy. Okay, and that, my dears, is the end of your basic introduction to chemistry. I hope it was a useful review.